Hi, my name is Suraj Matthew Thomas, and today I'm going to demo how to deploy a simple model using Python SDK. In the last assignment, we did how to use the graphical user interface of Azure Machine Learning Studio to create these resources and compute spaces and deploy the model. But now let's look at how we can do that using the Jupyter Notebook and the Python code. So let me go ahead and share my screen. Okay. Okay, so the first thing that we do is to import the necessary libraries like Azure Core, Azure ML Core, and you have to import all the other dependencies from these libraries like workspace, environment, experiment, script run config, the target compute that is for deploying the model, and as well as the AKS compute. Then we go ahead and import web service and AKS web service. So these are all methods within the Azure ML core, which we are invoking that we will be using downstream in the code. The second thing that we're doing is after importing the necessary libraries is we are going ahead and declaring variables. And these variables, we are going to assign these values so that we can call these variables when we have to pass the attributes into the methods. So basically the resource name, that is the resource group name that we are going to create, the workspace name, then the subscription ID. This is the pay-as-you-go ID because the student ID is not working for me. I had subscribed for the pay-as-you-go ID. And you know, the target compute, the name and the experiment name. So these are the variables that we are defining, the key value variables, key value, so that we can invoke them later on. The next, we are going to go ahead and create a workspace. So for creating a workspace, we're going to write this code in a try exception block, where it's going to check whether there is an existing workspace that is already there, and then quit if it exists. And if it doesn't, it's going to create a workspace. And like I said, you know, workspace dot create is the method that is being used, and we're going to pass the variables that we had declared previously. These variables are, you know, the workspace name, that is the value is being passed, resource group name, that is the resource name, create resource group in the subscription ID, and we also select the location, that is the East US location, and we're going to write that into the Azure portal. So once this is executed, if we go to the Azure portal, I'm sorry, if you go to the Azure portal and go to resource group, okay, just go to resource group. So you can see the resource group that is created over here, SMT SIG. So let's go back and see that. SMT SIG 788PY SDK is the name that is given. So that has been created. Now, if you click on this resource group, you'll find the resources that are being created over here. So initially, they will create the key vault, the storage, and the Azure ML Studio. So once this is there, this is because of the deployment, all these are created, the Kubernetes space and also. Let's go ahead and open the workspace over here. So once you go here, you will be able to launch the studio. So once the studio is launched, you can see the name SMTPY SDK. So SMTPY SDK is the workspace name that you are given, and it has been created in the East US location. Okay. So the next one is we just getting the configurations, whatever we have created, we're just getting the configuration names. Next, we are going to create the compute space. So the compute space is used to allocate a virtual machine where the model will be trained. So we usually go over here. If you go back to the ML Studio, you go to the compute space, go to compute cluster, and we go ahead and using this GUI, we are going to create a new compute cluster, right? So instead of doing that through Python SDK, what we are doing is we are provisioning that. See, again, it's a try exception block. And once the provision configuration is there, we're going to use the AML compute method to provision these configurations. So the VM size that we use is the DSV series, V2 series, DS V2 series, or the DV2 series. And under that, you have the standard D3 V2 is what I'm using. The nodes that are specified, and then we are going to create using the compute target. So we're going to pass the variables as a workspace name, the AML compute, and the provisioning configuration, right? Compute target and the provisioning configuration. Compute target was declared earlier in the variables. The provisioning config is what is declared over here. So we are passing these values as attributes into this for it to execute. Right. So once that is done, we put for wait for completion, we put a timer over here and we start to execute that. So once that is executed, you can see the new compute space has been created. So once this is created, we can go back to, sorry, we can go back to the compute and see PY SDK cluster has been created. If you go inside, you can see how the allocation is being done and all the configurations that are there. So we specified 1 to 4 nodes we have done, and the idle seconds before scale down, we have specified 3000. All these has been, succeeded in creating. We have succeeded in creating the PY SDK cluster, right? So after that, what we are going to do is once the, sorry, let's go here. So once the compute space has been created, we're going to create the AKS cluster. So the AKS cluster, if you see the AKS compute, when we use the GUI, we went into Kubernetes and we created an AKS compute. So this is basically used for deploying the model. The final deployment of the model, we have to invoke this space for getting the API key, the unique API key, or the REST API key. So once that code is run, you can get the AKS cluster also as created. So if you see over here, it is a provisioning, and once this is done, it is created. So basically, it's the same try exception block. We are importing certain modules like the compute target and the compute target exception, and we are just passing the attributes of the variables that were declared previously, okay, except the AKS name that is defined over here. The provisioning configuration, again, we are using the provisioning default configuration to provision the AKS compute space, right? So once that is done, we are going to go ahead and create an experiment. So the experiment name was declared before. If you see over here, experiment name PYSDK EXP8. So once the experiment name has been given into this attribute, into the experiment will be created. So once you go inside, you go to jobs, you see over here, you see the experiment that is created. The experiment was created as a Dreamy Land. This was the one that was created, right? So you have all the details over here as to what has been created. So let's go back. So once that is there, let's go back to the code. The next one is after creating the experiment, we are setting the environment variables. The environment variables, from the name we are giving, the environment name we are giving, the file path is env hard.yml file. So this YML file is the environment file that we are giving for creating the environment. So if you want to see what the environment file is, let me just say environment hard. Right. So these are basically the name of the environment, what are the dependencies, the Python, whatever, the Anaconda, the pip, we are giving Azure ML, SDK, and Pandas. So we're just passing the environment in a YML format into this code. So once that is there, we are going to config, we are going to run the script, the entry script as train-hard.py. Train-hard.py is the problem that we have taken here is to predict heart attacks. This was done in the second assignment, that is 1.2. So I've used the same model, and it was an assignment to see which was better, the decision tree or the random forest. and I selected that the random forest did much better than the decision tree. So the entire modeling we didn't do. We did uh, the descriptive analytics over there. We did all the cleaning and everything over there, but the model building alone has been put into um, the trainheart.py. So if you go over here, the model building, we've just read the combined CSV file, that is the data file, and we have invoked the random forest, and we're just putting the, splitting the data and then training the model. And then we are outputting the confusion matrix, the accuracy, right? So this is basically training the model. We have just put the model inside the .py file and we are invoking it over here. And the compute target is we have declared, we have created the target space that was the compute cluster we had created before. So that is what we are mentioning over here on the environment that we have declared here, and we are executing. So this took around 1 hour for me. I do not know why it took so long, but then 1 hour, 30 minutes is what it took for me to do this, right? So once that is done, right, once the environment is created, let's go back to this space and see the environment. So if you see, we've created this the heart attack environment over here, right? And whatever we have uploaded, right, we have uploaded the project environment, right? So whatever we have uploaded is coming over here as Conda as well. So you can see the build logs, the context, conda.yml. So that has been uploaded. So once the environment is done, let's go back to the SDK portal. Let's look at this. Okay. So we come for the registration of the model. So the registration of the model is we need to register the model next, where we get the pickled output, the pickled file out of training the model. So that is being passed, the name of the model, tags if you want to create tags just for easy identification, and then the description of what the model is actually going to do on the workspace. And once the model is registered, you can go back and see how the model is registered. If you see how that ML model, this has been registered, right? So once the model is registered, you get this as the output. And then we go to deploying the model. So before we deploy the model, we have to set some configurations. So we are setting, say, inference configuration, which is again the entry script that is score.py. Okay. And we have the conda file environment heart.yml. So, and we pass the model. Once the model is there, we create the environment again. So once we create the environment, we use the AKS config to deploy it, right? So we come here, we see what are the compute spaces, and we come here and you kind of deploy the model. So you use model.deploy and and pass the attributes like the workspace, the AKS server as service name, the inference config that we have done before over here, the values over here, the deployment config, and the deployment target. So now if you go ahead and run this, right? So so when you go ahead and run this, what you're going to see in the endpoint is the AKS deploy model, right? The AKS deploy model, and at the end of it, once the transitioning and all is done, it'll go into the unhealthy state, it'll go into the transition state, and then when it comes to the healthy state, you get a REST end API. So this API is kind of used to invoke into software applications, so the model can be integrated into software applications, and then the inputs can be given and the prediction can be done using this test. Right. So this is a quick overview as to how SDK can be used to deploy the model instead of using the graphical user interface of machine learning. I mean, that's more intuitive, that's more easier to do, but then to understand the real crux of what is happening behind the scenes, the Python SDK is good to understand and see how the resources and the compute spaces are being allocated for the model to get deployed. Thank you.